Okay, welcome back. We're doing the second part of applications, which was some of the things we did for trigonometry. So we can see them here. So from a point of view at the base of a wall, 60 metres from the wall, so you're standing here. The angle of elevation of the top of the wall is 22, so there it is marked. Find the height of the wall. So we want this height. What is the height of this wall? Height equals what? So that's the question that's being asked. So it's just a SOHCAHTOA, isn't it? So opposite over hypotenuse. So there's our hypotenuse, but we don't have a hypotenuse. What we do have is an opposite and an adjacent. So we'll get the height by saying the tan, TOA. TOA is opposite over adjacent. That's the two that we're going to use. So tan 22 is equal to the unknown height divided by the known length of x is 60. So there we go, opposite over adjacent. So we're going to multiply both sides by 60 and 60, and so h will be equal to 60 tan 22. Make sure your calculator is in degrees. So we've got 22 tan times 60 is 24.24. 4 goes down, so we'll leave it at 24.24. 24.2 metres. Very good. From a point adjacent a lighthouse, the top of a lighthouse, 70 metres above the water, the angle of depression to a fishing boat is 31 degrees. So the fishing boat's here by the look of it. Okay. A little fishing boat. Now, how far is the bottom is the boat from the lighthouse? So we're looking for this one here. We're looking for that. Okay. So, what do we know about angles? What do we know about angles? Well, in your work you will have encountered F, C, Z. One hopes. These little dots here represent equivalent angles. Okay, so equivalent angles. So FCZ with your parallel lines, okay, means that this angle here is also this angle here. So like the one above where we did TOA, we can do opposite over adjacent for tan. Now it's a right angle triangle, although that should be drawn. Really, that should be drawn in. And so the internal angle is 180 degrees. Okay. So we can work out this angle here. Alright, so the angle here, which we'll call alpha. So we've got 180 is equal to 90 plus 31 plus alpha. So subtracting both sides, alpha will be equal to 180 minus 90 minus 31. So 90 minus 31 will be 59. So alpha up here is equal to 59 degrees. Okay. So you can make life a bit easier if you want to know the distance and you want to make your equation simple. Instead of using the 31 degrees, you can use the 59 degrees, opposite over adjacent. Opposite over adjacent for this one. Looking through there, opposite over adjacent. Whereas this one here would be opposite over adjacent, which would be 70 over, and you'd have to rearrange everything twice. But just doing it from there, it doesn't really matter. We can do tan 59. So I'll do both just to show you the difference, because I'm interested in you being relaxed about things. So if we do tan TOA 59, Okay, it will be opposite D over 70. And then that's just a very straightforward computation, isn't it? You're going to do 70, 70. So D will be equal to 70, 10, 59. Okay, so that'll be your D. Or we could have done TOA for 31. Okay, 10, 31 degrees would be opposite over adjacent, so that's a different opposite and a different adjacent. You've got to stick to your tan rules. So that would be 70 over D. The issue here is we have to rearrange for D. And so what we'll end up with is D would be equal to 70 divided by 1031. Okay, so you can do both of those on the calculator to show that they're in fact the same thing. Okay, so 5910 times 70, that was making up the extra angle, 116.5. Okay, that's that one. And then this one over here is 70 divided by the tan of 31. Just squeeze that in. So 70 divided by the tan of 31, which is equal to 116.5. Happy days. So either way, as long as you manage it, so that's one extra calculation to get a simpler version, or there's a rearrangement that has to happen. Okay, there's a rearrangement that has to happen to get D there. All right. So for this one then, the point from the horizontal ground. So I might put this on the sheet here and add that in. From the point on the ground, the angle of elevation of an aeroplane is 17. If they're at 3,500, find the distance from the point of observation. So this is a fun thing to do because often what we see is we see aircraft away, don't we? So this is sort of B actually. We'll just call this B. And we've got B. And so it's said there's the ground. You're a rough on ground. The plane is flying. Okay, so we've got like a bit of a fish. Got super tails, super wings. Okay, and it's at 3,500 feet. Meters. Wow. Okay, so you're standing here looking at this plane, and that angle is coming up for 17.3 degrees. Okay, and we're looking at what's the distance from you? Okay, what's the distance from you to the plane? So we've got to think about our triangle. Toa. Soccer, Toa. So we're going to do sine, opposite over hypotenuse. There you go. Sine 17.3 is opposite over hypotenuse. We've got 3,500 over D. So it's a rearrangement. So we're going to times by D. So we get 3,500 times D. Once you do to one side, you do to the other. I'll cancel. And then we're going to divide by sine 17.3. Divide by sine. Just do to one side, you do to the other. So therefore, D is equal to 3,500 divided by sine 17.3. Okay, so we'll do our calculator. So we've got 3,500 divided by 17.3. But before we press the go button, the sign of 17.3. So it's going to be a big number. How many 0.2s in one? 5. There's 3,505, so that's a lot. There you go, 11,000. 69.656 ... So we'll say that that's approximately 7,069.70 nearest whole kilometre. Wow, 3,500 metres, which is 11.7 kilometres. Just make sure you get that distinction between here and here. Okay, just make sure you get that distinction, that's important. All right, so 11 kilometres. So when you see something up high in the air, it's just around about cloud level. So these would be about clouds. Cloud level's kind of around here, aren't they? So if you see one going through the clouds, that's about right. So it's going to be 11 kilometres from where you are. And then you can think about where you are. So your little suburb, your town, okay, at 11 kilometres, where's that? From where I live, there's a few places that could be. Okay, a few city centres that it could be 11 kilometres away. It's quite a long way. So, and that's only the line of sight. We could work this one out just to get that length as well. We could get the horizontal length. All right, a bit of fun for that. All right, from the top of the tree, an angle of depression from the top of the tree of a dog on the ground is 43 degrees. Okay, the horizontal distance of the dog from the base of the tree is 63. How far is the dog from the top of the tree? So it wants to know the height of the tree, so you can do this remotely. All right, so for C, we need to write the question down in a mathsy form, but before we get to the mathsy form, we might have a diagram. So we've got a tree. Okay. Often they're a bit symmetrical, aren't they? Okay, a tree. You can make it a bit more seesaw if you want to. Anyway, I'll let you do your tree. That's my tree. Okay, now we don't know the height. The dog's looking up, seeing that. Well, what's the height? But we're told that the dog is 64.3 metres. So here's your little doggo. Copy ears, the tail, some legs. Okay, and an eye. We need an eye there, please. Okay, so the doggo's looking up at the top. And we're told that the angle of depression is 43.6. Okay, so by our FCZ idea, and we didn't talk about there, but those are complementary. For Z, those angles are the same, so those two have the equal angles. This one adds up to 180. So we've got equal angles, so that means this is also 43.6. Okay, because of this geometric thing here with parallel lines. Parallel lines, they have to be parallel. Bit of basic geometry from year 9. Alright, so how high is the tree? Toa is opposite over adjacent. So tan 43.6 will be equal to the height opposite over adjacent. Okay, so multiplying both, what you do to one side, you do to the other, one in disguise, h is equal to 63.4, 63.4, tan 43.6. So that's equal to, using our calculator in degrees, 43.6. I'll have the tan of that, please. And no, I don't want that. I pressed the button too quickly. 43.6. I'll have the tan of that, please. And we'll multiply that by 63.4. Get 60.37, which will round. Which will round to 60.4. metres. Very good. All right, so the only thing left to do then is the area of a sector. This will come up because the area of a sector is one of those things that in geometry, some geometries creep into the Maths 1 course just by virtue of need. So it's not because anybody plans to cruel you or derail you or anything like that. So it's quite an important idea. Okay, so we just want to consider this particular idea, and so what we consider is radians. So just be careful now. Make sure that your calculator is in radians if the subject of the question is in radians, or if the subject of the question is in degrees. So rotational angles are often expressed in radians when we move to a different form of problem. Okay. Now the idea here is that the circle has a circumference of the circumference of a circle is 2 pi r, and the area of a circle is pi r squared. Now when you take a segment of the circle, it's a fraction of the overall. It's a fraction of the overall. Okay? So when they're denoted with this length and radius, it's a proportion. So what we can say is that the relative ratios of the two areas give rise to our length of the arc. So the length of the arc, it's often very confusing, but they mix up L and S. So the length of the arc S, okay, so the length of the arc S, and the area of the sector. Okay, now so they're just a proportion. So we can write the circumference of a circle as 2 pi r, and we can say that the angle subtended by the length S, the angle subtended by the length S is the same as 2 pi r is to C. Now that's a very mathsy way to put it. So S circumference is to 2 pi r as S is to theta r. So we can kind of think of it like that. C is the circumference is to 2 pi r as the segment length is to theta r. So that's a kind of a thing that we can do there in relation to our proportions. And you can do the same thing for area. You can say that the r theta combination, r squared theta combination, is a proportion to the total area, and it's theta that makes the difference. So A is to pi r squared, that the area of the arc, the area of the circle, the circumference of the circle, the length of the arc is to the area of the arc is to r squared theta. Okay, on 2. So we can do a bit of a workshop on that at some point if we need to. But otherwise we just take the results of that, and we can see clearly that there'll be some cancellations as you go through. And so we'll end up with these results here. Okay, so what we want to do is consider question example sector theta has 30 degrees in R, find S and A. Okay, so 30 degrees by recognition, the smaller angle has the bigger denominator. Pi on 6 is 30 degrees. That's from your white sheet. Okay, your white sheet that you've been working on. And compiling tells you that 30 degrees is pi on 6. Okay, so S is going to be in radians, so R theta, which is 3.3 multiplied by pi on 6, which is 1.73 centimetres. Okay, the area in radians will be equal to R squared theta on 2, which will be 3.3 squared, and using radians, pi on 6, and there's already a 2 down there, so that's pi on 6, 2.85 centimetres squared. Okay, so just be mindful of that, and we can get that proportion working. Alright, for the second one, a sector has S is 6 and a radius of 5, so S is equal to R theta in radians. Okay, so we've got 6 is equal to 5 theta, therefore theta is equal to 6 over 5, which equals 1.2, and that's in radians. Okay, now it's very simple to convert that. There are 180 degrees in pi radians, so if we divide either one, so we'll do it two ways. We'll divide by 180 and we'll divide by pi to get our two sets. So 180, if we divide through by 180, we'll get 1 degree is equal to pi on the 180. So if you want to find out 60 degrees, you just multiply everything by 60. So it'll be 60 times 1 equals pi on 180. That's the unitary method. At school, that's taught as the unitary method. Okay. Here, we'll get 1 radian would be equal to 180 divided by pi. And so if you want to calculate how many 1.2 is, you just times both sides by 1.2. So, if we've got 1.2, we'll take our 180 over pi is equal to 1, and we'll just multiply by 1.2. So you get 1.2 on the left and 1.2 on the right. Okay, and you'll end up with an angle. So we'll just do that on our calculator. So 1 pi, there it is. Oops. So 180 divided by pi times 1.2, 68.7 degrees, which approximates to 69 degrees, is approximately 1.2 grams. Okay, so you've got it back into degrees, so you can get your area. That's your first part. You've found your angle. Okay, the area though has got to be in radians. I'm just going to use this equation up here. So our area will be equal to 1.2 radius is 5 in this question, times 1.2 over 2. And so we'll get 5 5 is 25. 1.2 over 2 is 25 times 0.6. So 60% of 25. 10% of 25 is 2.5, so 6 of those. 12, 15 centimetres squared. Okay, so they're your answers for those. So just be patient as you're working through problems related to converting degrees and radians. Now, I'm not overemphasising that because the exact values trick teaches you to operate in radians anyway. So if you're operating in radians anyway, it shouldn't matter. Having to come back and do a unitary method style conversion of this is a very low-level problem solving, but it gets a bit mischievous. But I don't want you to think that it's representative. All right, we'll leave that there, and that'll complete our applications for this week. Thank you.